Hello, students. Welcome back to the channel. So, if you are preparing for your class 10th board exam 2026 and you want to score above 90 marks in mathematics, then this video is extremely important for you. Because in today's video, I'm going to discuss the most important and highly expected math question, chapter wise, that have maximum chances of appearing in your board exams. They are not random questions. These are board pattern, concept based, and repeatedly asked question. So make sure you watch this video till end. Keep your notebooks ready and mark every important question. We are going to do real numbers today and irrational number proof. So let's begin. Okay. So let's begin with question number one. Our first question is find HCF of 4052 and 12576. Now we have to do this using Euclid's method. Okay. Now first understand what is Euclid's method. You have to remember it as A equals to BQ plus R. This is something which should pop in your head when you listen Euclid's method. A equals to BQ plus R. Now A is your bigger number and B is your smaller number. A here will be 12576 and B will be 4052. Now you have to write this B in terms of A. Or you can say you have to write A as factors of B. What I mean by that is, for example, you have 26 and 5. How I can write this 26 in terms of 5? 26 can be 5 into 5 plus 1, right? How I can do it? 5 5s are 25 plus 1, we will get 26, correct? In this sense, we have to write 12576 in terms of B. Let's do it. How can I do it? 12576 is equals to 4052. Now, how many times I can multiply to get nearest to this number? 4 threes are 12, we know. 4 threes are 12. Let's see. 40523, and what will be left? Around 420. After calculating it, you will get this 12576 exactly. Now, this was our A, this was our B. For the second step, this number becomes B and this number becomes A and this number becomes B. So now our previous B becomes A, 4052, and the remainder part becomes B, 420, around 9 times plus 272. Same diagonally move, 420 becomes A and 272 becomes B, around 148. Same diagonal method, 272 becomes A and 148 into 1 plus 124. Yes. Now 148 again diagonally. 148 equals to 124 into 1 plus 24. Again diagonally. 124 equals to 24 into 5 plus 4. Again diagonally. 24 equals to 4 into 6 plus 0. That is where you stop. When you get your R equals to 0, then the B value, the value which is at the B's place becomes your HCF. Therefore, the final answer will be 12576 and 4052 will have HCF as 4. What is our Q to stop? Whenever the remainder is 0, that's where you stop. And whatever the value is at B's place becomes your HCF. That's how you do it. In short, you have to remember that in Euclid's method, A equals to BQ plus R. You have to place the bigger number as A, smaller number as B. You solve it, you keep on changing your A and B diagonally, and you stop when the R is 0. And that's where you get your HCF as 4. Easy? Okay. Now, let's move to our second question. This question is again very repeated, not exactly, but similar kind of question is always present in every year's paper. Root 5, we have to prove that root 5 is irrational. We have to prove that root 5 is irrational. How you can do it? What So for these kind of question, the steps are same. They are fixed. You just have to remember the steps and understand why we are doing those steps. First step, what we do is we assume that root 5 is rational. This is our assumption. Now, why do we assume this? Because if we can prove that root 5 is rational as wrong, if we will prove it wrong, therefore our assumption will also be wrong. And if our assumption is wrong, therefore the opposite must be true. So in this, we apply the opposite method. We assume root 5 as rational and then we prove ourselves as wrong. Okay. Now, what is rational number? Rational number is anything that can be written as P upon Q form, where P and Q are coprime and Q is not equals to 0. Coprime are those number which are not further divisible, which are not further divisible, which are not present in each other's table or any other common numbers table at all. For example, 2 and 3 are coprime. 2 and 3, they are not present in each other's table and any other table. For example, 4 and 7, all these numbers are coprime numbers. Okay. So now we have assumed that root 5 is rational, therefore root 5 must be equals to P upon Q. Necessary. Now we can't solve it further, so let's remove the root by squaring both sides. We'll square both sides. By squaring both sides, we will get, let's see, 5 equals to p square upon q square. And we can write this as p square equals to 5q square. Okay. Now here we can see that we are writing p square in terms or in multiples of 5. Therefore, p square must be divisible by 5. Obviously, you're writing in terms of multiples of 5. P square must be divisible by 5, which also means that p is divisible by 5. Obviously, for example, 4 is divisible by 2. Then 4 squared 16 is also divisible by 2. That is true for each and every number. Okay. Now, let's see. We have proved P is also divisible by Q. Now what we will do, we can assume that P equals to 5K. Since P is divisible by 5, we can assume that P is equals to 5K, obviously. Now let's substitute this P in this equation number 1. 5K whole square equals to 5Q square. This is 25K square equals to 5Q square. K square equals to 5K square equals to Q square. This you will get after solving. Why I am putting P equals to 5K? P is divisible by 5. Therefore, any number which is divisible by 5 or any other number, let's say 100 is divisible by 5, I can write 100 as 5 into 20. Yes, I can write it. Similarly, if P is divisible by 5, I can write it in terms of 5 into equals to 5K. Now I'm putting the value of P in equation number 1 and I'm getting this. Now again from here we can see that Q square is divisible by 5 because Q square is written in the multiples of 5. Therefore Q must also be divisible by 5. Okay. Now we have got P divisible by 5. We have got Q divisible by 5. but root 5 was P upon Q. Now this is also divisible by 5. This is also divisible by 5. This can't be coprime. Can it be? Can it be coprime? Both our numbers are divisible by 5. No, it cannot be coprime. That means root 5 P upon Q. Our assumption, our, I'm sorry, P upon Q, our assumption was wrong. This assumption was wrong. It is not rational. And if it is not rational, it must be irrational. Hence, we have proved that root 5 is irrational number. Got it? You can take screenshot if you want. Take a screenshot. This is a little rough version. You have to write same steps only, but in little more neat form. You can take screenshot for this also. Or this, yes. Perfect. So these were two important questions, Euclid method and proving a number as irrational. For the next class, I'll bring two more important questions, which will definitely increase your score in your board exams. And we'll meet tomorrow. Let's grow with Isha.